Hello, welcome back for lesson 2.3. Today we're going to look at functions. Functions are basically just a way to describe how a set of inputs are related to a set of outputs. Inputs are usually what we call our independent variable. They are not dependent on what happens with the output. Okay, we usually use X to refer to our input variables. The dependent variable depends on what happened with the independent variable. They're usually used with the letter Y. Now, the thing with a function is that every element A only has one element in B. So you can see that here, this element only goes to this element in B. This element only has one element in B. This element only has one element in B. And this element only has one element in B. Okay, so we're going to give a couple different descriptions of functions today in this lesson. There's actually 4 ways that we can show functions. One is using words to describe functions. We can use a table of input and outputs to describe functions. We can use symbolically in an equation. And the 4th way is going to be using pictures or graphs, and that's going to be in lesson 2.4. Another important thing of functions is the domain and range. The domain is the allowed inputs that can go into the function or the machine. I kind of think of functions are like machines. The range are going to be the set of all outputs that come out of those machines. And then we also name our functions. So for instance, this function here would be the name f. It's the function f. And this symbol right here, we pronounce it as f of x. It's not being multiplied. It's saying that I'm calling this function f, and I'm letting the reader know that x is my input for my variable. Okay, so we're going to use that in this lesson as well. So example 1 has the function f, and it's a negative 4x minus 1, and we want to evaluate the function at 3. That's what this symbol says. Evaluate the function f when x is 3. So we are going to put 3 in for x. Now, because the function has 4 being multiplied by x, I'm going to show that multiplication with the parentheses so that the numbers are not next to each other and mistakenly as the number 43. So I'm showing the multiplication. So negative 4 times 3 is a negative 12, minus 1 is a negative 13. When I evaluate the function at 3, my output is a negative 13. The next one is the function evaluated at a negative 2. So this becomes multiplication here. It becomes a positive 8, minus 1 is 7. Letter C is evaluating the function at 0. And that results in a negative 1. As we move on in algebra, we're going to be evaluating functions at using other expressions as our input. And so we're going to practice that today. So I'm going to put in the expression x plus 1 as my input. So I have to show that. I'm going to put in x plus 1. And now because it's an expression that still has a variable in it, I won't actually arrive at a value answer like I did up here, but I still can simplify. So I can at least use my distributive property here. So a negative 4x minus 4 subtracting 1, and that simplifies to negative 4x minus 5. Example 2. So it says for the following function, f of x, the function is a square root function, the square root of 2x plus 5, and we want to evaluate this function at 3. So when I put in 3 for x, I get the square root of 6 plus 5, or the square root of 11. And then we're going to evaluate at a -2. The square root of 11 is an irrational number, so we'll leave that. The square root of 1 is the integer 1, so we'll simplify that. And then we're going to evaluate at 0. So you can see my process looks the same each time, except for I'm just putting in the input, a different input. Square root of 5 is irrational, so we're going to leave it as that. And then we're going to evaluate this again at x plus 1, similar to what we did in example 1. So I'm just going to simplify where I can, distributing my 2. And I end up with the square root of 2x plus 7 is the simplified version. Let's go to example 3. Example 3 is at the top of this page. Example 3 is a rational expression, t squared plus 1 over t minus 2. And again, we want to evaluate at the same values we have previously. So 3 will get squared. 3 squared is 9. So we end up with 10. Let's evaluate it at -2. So when an input is going to be raised to an exponent, like we have here, we have to make sure we put that input in parentheses so that the entire -2 gets squared. Because a -2 squared is a +4. We have a result of 5 over -4, or you could write it as a -5 over 4. Either of those works. The negative can go on top or bottom. And evaluating the function at 0. Again, we can put the negative on top or bottom. I like to put my negative in the numerator on top, but that's up to you. And then again, we're going to evaluate at t plus 1. So wherever I see t, I'm going to put t plus 1. And I'm going to make sure I put that in parentheses because I have to square t plus 1. And I have to square this. So I'm going to do that off to the side here. T plus 1 times t plus 1. Using my FOIL, or my first, outside, inside, and last. What I really want you to take away is when you're multiplying expressions together, if you want to know how many products or how many multiplications you should have, you're going to count how many terms. So this has 2 terms. T is a term and 1 is a term. Remember that terms are variables or constants that are being added or subtracted. So I have 2 terms times this has 2 terms. So I should have 4 products or 4 multiplications. When I simplify, excuse me, products. So when I multiply, I should have 4 products. When I simplify, I might have some combined terms at the end. I might have fewer than 4 terms left, but I should have 4 products. So t times t is t squared. T times 1 is t. And then I also have this 1 times t, so that's a t. And then this 1 times 1 is a 1. So those are my 4 products, but these 2 in the middle are like terms. So it simplifies to t squared plus 2t plus 1. So that's what goes in over here. T squared plus 2t plus 1 plus the original 1 all over t plus 1 minus 2. So I'm going to combine what I can on top. So I have t squared plus 2t plus 2 over t minus 1. And that's my final answer. Okay. Example 4 is asking us to describe whether a function is being described here. Determine that. And so letter A says a person's head is the input variable. Oops, spelling. And his or her weight is the output variable. So if we just say height is the input and weight is the output, a person, any height could go to multiple weights, right? I could be the same height. I could have I could be 5 foot 2 inches and I could weigh 128 pounds, and somebody else that's 5 foot 2 might only weigh 119 pounds. So this would not be a function because these heights are going to more than one weight. B says the input variable is the barcode on a product at a store, and the output variable is the name of the product. This should be a function because every barcode should only have one name. So this is a function. Letter C, we have some inputs and outputs here. So -2 goes to a -1/3, -1 goes to 0, and oops, -1 is also trying to go to 2. So this is not a function. Because -1 cannot have 2 outputs if it's a true function. Okay. That's fine. It says it costs a watchmaker $20 for each watch manufactured over and above the watchmaker's fixed cost of $5,000. Express the manufacturing cost in dollars as a function of the number of watches produced. So I'm going to call my cost C, and my input is going to be number of watches. So I'm going to say W for watches. So my function is, my cost is affected by the number of watches. And it looks like for every watch, it's going to cost $20. So 20 times every watch, plus they said this $5,000 fixed cost that you pay no matter what, that's going to be a constant because it's a fixed cost. So it says, how much does it cost for 35 watches to be manufactured? And so that would be the cost at 35. So this tells the reader that I'm finding the cost when my number of watches is 35. So I'm going to say 20 times 35 plus 5,000 should be 700 plus 5,000. So the cost in dollars should be 5,700. Find the domain of this function which makes sense in the real world. So remember, the domain are the allowed values that could go in for the input, and the input is the number of watches. So we would never make negative number of watches. It's possible that they could say they're not going to manufacture any. So I would say the domain would be bracket at 0 because we could have 0 watches up to a positive infinity with the parentheses. And remember, we're practicing using this interval notation because it's handy to know. Example 6, find the domain of each function below. So these functions here, we are actually going to really build on the skills of this quadratic. We're going to learn this rational function, this square root function later on in the semester. These are just to get us practice to understand what the domain means. So it's the allowed input. So I'm going to let you know what they are. Don't be concerned if you're still struggling to understand why. So the domain, what I'm allowed to put in here is I can square any number. There's nothing that would come up illegal in math. So that means I can put any number in here. So any real number, but we're going to show that in interval form. So that's going to be a negative infinity to a positive infinity. Now in letter B, we do not want to have a 0 in the denominator. Okay, so that means we can't let 2x plus 1 equal 0. It cannot equal 0. And so to do that, I'm going to solve for x and find out what that is. So if I subtract 1 from both sides and divide by 2, I find out that x cannot equal a negative 1/2. It can be anything else. So that means my interval is going to be a negative infinity up to a negative 1/2 with an open parentheses, but because it can't actually equal that. And I'm going to union that starting at another negative 1/2 up to a positive infinity. This just tells the reader that actually equaling a negative 1/2 is the only limitation that we have. Okay, letter C. We've got two things. One is we can't have square root of a square root of x minus 5 cannot equal 0, right? Because it's in the denominator. And then a square root itself can't be less than 0. So that means the x minus 5 can't be less than 0. So we can't have, if we add 5 to both sides, we can't have anything less than 5. And we can't let it equal 0. So basically our restrictions are less than 5. So I have to have anything bigger than 5, bigger or equal to, it's got to be bigger than 5. It can't even be equal to 5. So that means my domain is going to be starting at 5 with an open parenthesis because it can't actually equal 5, and it's going to go up to a positive infinity. That is the end of 2.3. Catch me back for another video.